So in this example, we're given a polynomial and we're asked to find list all of the possible rational roots. So the theorem says to write the possibilities as a fraction and then simplify them. So your numerator will be factors of the constant term, and your denominator will be factors of the leading term. So factors of 18 plus or minus 1 plus or minus 2 plus or minus 3 plus or minus 6 plus or minus 9 plus or minus 18. Factors of 9 plus or minus 1 plus or minus 3 plus or minus 9. All right, so from here to write all of the factors, we have to take each numerator number, like for instance this number, and divide it by all three denominators, okay? So we're going to have a lot of roots here. So starting with this pair, this is 1 divided by 1, so it's plus or minus 1. Then looking at this pair, that's 1 divided by 3, so plus or minus 1/3. And then looking at this pair, 1 divided by 9, so plus or minus 1/9. Okay, so we are done with the 1. Now let's look at the 2. So 2 divided by 1, so it's plus or minus 2. 2 divided by 3, that's plus or minus 2/3. And 2 divided by 9, plus or minus 2/9. Okay, we're done with the 2. Now we're on to the 3. So 3 divided by 1 is plus or minus 3. 3 divided by 3 is just 1, and we already have that, so we don't need to write that again. And then 3 divided by 9, 3/9 reduces as 1/3, and we already have that in our list here. All right, so the 3 is done. Next, we're on to the 6. So 6 divided by 1 is plus or minus 6. 6 divided by 3 is 2, and we already have that on our list, so we don't need to write it again. And 6 divided by 9 reduces as 2/3, and we already have that in our list. 6 is done. On to the 9. 9 divided by 1, so plus or minus 9. 9 divided by 3 is 3, and we already have that in our list here, so we don't need to write that. And then 9 divided by 9 is 1, and we already have that on our list. So the 9 is finished. We are on to the 18. So 18 divided by 1 is plus or minus 18. 18 divided by 3 is 6, and we already have that in our list. And lastly, 18 divided by 9 is 2, and we already have that in our list. So this completes all of the possible rational roots.